So we're talking about velocity. Now, in order to do that, we need to figure out how to go from a position graph to a velocity graph, okay? So I'm going to be showing you all these things as position graphs, and then we're going to talk about describing that motion, like we were doing at the end of the last lesson in lesson 4. Okay, that was part of lesson 4, describing motion. And then we are going to start taking the graphs that we've described that are position graphs, and we're going to convert them into velocity graphs. So that's what this is all about. The first 2 pages of these notes are going to be all about that. So if you want to write this stuff down as we go, that'd be a really good idea. I've shared the notes sheet with you if you want to like write on that digitally or print it or whatever, or you can just write these down on your own. You can just make quick little charts and graphs. It'll be fine. So what we're going to do is we're going to start here by describing the 3 parts of motion in our graph. So we've got a position graph, position on the X, time on the Y, okay? What we're going to want to do is describe part 1, part 2, and part 3, okay? So I'm going to actually use the same colors that they're using. That looks like orange. I'm just going to call it red because it's easier to see. So part 1's down here, okay? So red's part 1. What's happening here? Describe this motion. Well, we're starting at reference point. Start at the RP. We are going to be moving away from it with away in the positive direction, because you could be going away in the negative direction, with a positive constant, and we'll call it fast velocity. And if we wanted to actually calculate the velocity, we could do that. We'd calculate the slope, right? So we go up 2 over 1, so the velocity would actually be 2 meters per second here. Okay, you don't have to do that, but I did just because I can, right? So I went up to 1, 2 over 1. So 1, 2 over 1. So it's 2 over 1. So the rise over run is the slope. Okay, so that should describe that one. And then let's switch colors and we'll go blue here. We're going to go to section 2. This is section 2. In section 2, we're at position number 2. So we're at 2, we'll call it 2 meters. And we stay there for an entire second. I probably should have told you in part 1 that we were actually doing that motion for 1 second, okay, because it was from 0 to 1 in terms of time. So that's going to mark us here, and then blue ends here, okay, and that's all of the motion that we've done so far. So then this third part here is part 3, that's number 3. So we're going down, which means we're going to have a negative constant velocity, okay, and we can calculate the velocity again by doing rise over run. This time it's, it's down 1 over 1, so it's 1 over 1, so the slope is 1. So 1 meter per second, if we say that. And we're moving, ending at the reference point. And let's see, it takes 2 seconds. 2 seconds. Okay, so that's describing that motion. We described the whole motion, and now we should be able to take this and convert it to what we are going to do as a velocity graph, which is graphing the velocity. And remember, velocity, the reason I was calculating the slope here is because velocity is the slope of a position graph. Okay, so let's put these 2 things together down at the bottom here. So instead of describing the motion, just write whether the velocity or the slope is positive, negative, or 0, constant, speeding up or slowing down in each section. So let's go to step 1, section 1 here. In section 1, is our slope positive or negative? Well, our slope is positive. Well, how do we know that? The line's pointing up, right? So that's a positive slope. Is the slope constant? Yes. And what's the value of the slope in this case? We calculated it at 2. Remember, we went up 2 over 1, so the slope is 2. We're going 2 meters per second. Okay. In section 2, the slope is it's a flat line. So do we need to write positive or negative here? No, it's 0. There we go. Okay, 0. Okay, so we've got a slope of 0 here, and is that going to stay that way? Yeah, it's constant. It's constantly 0. And what's the value? It's 0, you guys. So when the line is flat on the position graph, that's the easy stuff. That's when you know the velocity has to be 0. Okay, so let's change back to green here, and we'll do that. Okay, so is this line pointing up or down? It's pointing down, so that means it has a negative slope. Is the slope constant? Yes. Remember, speeding up and slowing down will always be a curve, right, on the position graph. What's the value of this slope? We went down 1 over 1, so it's -1. Sorry, I probably should have mentioned that the velocity was -1 initially. If you corrected me during that time, thank you. You're the one who knew. Okay, so now let's practice graphing this stuff, okay? All right, here we go. So on the velocity graph, velocity goes on the y. This is time on the x. So as time goes by, we are going to be at these speeds for a certain amount of it. So for the first 1 second, from 0 to 1, we are going to be at a speed of +1, and it stays at +1 for that entire second. So what does that look like? Well, we started at a speed of 1, and for that entire second, we are at a speed of 1. Boom. That's our line. That's part 1 right there. Easy peasy, right? It's pretty much going to always be either flat or sloped, or a constant slope, but that's only if your speed's changing. So on this graph, we have constant, constant, constant. We're going to have flat, flat, flat. Okay? So let's do the next one. There is a 0 speed here from second 1 to second 2. And what does 0 look like on your graph? Well, it's a flat line at 0. There we go. Okay, now some of you are going to be like, well, do these lines connect? No, the lines do not connect. If you've done this in math class, it's like when there's a dot here that's open and there's a dot here that's closed, right? So like this one ends right on this line and this one begins right on this line, okay? So the instant that your speed is not 1 anymore, it becomes 0 according to this graph, right? So right here at this corner, as soon as you get to 1 second, boom, your graph changes from 1 meter per second to 0 meters per second. So that's part 2. Okay, so don't connect these lines. You could like dash in if you want, but like it doesn't. Don't. I wouldn't do that. I mean, if it helps you see it, then great. But I'm not gonna do that on mine because that messes with my head. Okay, next one. We know we have a negative slope or a negative speed rather, because the slope was negative, right? We know our speed has to be constant and the value is -1. So we're going to go down to -1 and we're going to draw a line. Flat one, because our slope stays constant. But this time it stays constant for 2 seconds, right? Because our time that this happened was from 2 to 3 to 4. That's 2 seconds, right? So that's our completed graph for the velocity, okay? So I just want you to think about that for a quick second and then we're going to go on. Okay, you know the drill. We're doing another part. This graph actually only has 2 parts, so we won't need to use part 3. You see there's only red and then there's a purpley bluish color. So we're going to do red and we're going to call it red and blue. So we'll call this part part 1 and we're going to call this part part 2. Okay, so then this will be in blue and this will be in red. All right, so we're going to describe the motion. Okay, you ready? So we're starting at the reference point. Then we are going to be going, move in the negative direction. And this is a very flat slope, right? So this is very slow. And then by the time we get down here, we're going to be going quite fast, right? So speeding up is how we describe that. And it's negative direction, right? Which we did already say, but I'll put it twice because I'm paranoid. Okay, so starting at 0, getting faster as we go. And it's going to be for how long? For 1 second, okay? Now in part 2, we start here, right? And the slope of this line is constant, so then we're going to have negative constant velocity. I don't know why I circled that. For it would be 2 seconds. You can see here's where the 3 would be. I'll just put a 3 there for our peace of mind. Man, sometimes you do things. For 2 seconds. Okay, there we go. Boom, done. That's it. Negative constant velocity for 2 seconds. What's the value of this velocity? Let's do the rise over run. We go down 1 over 2, so it's -1/2. So that's quite slow. So velocity equals -1/2, right? And then again, we are not going to need this third part down here. And I'm going to give you a second here to try and figure this out on your own. Then we're going to put it on the graph. Okay. Here we go. We are graphing, and we are going to start by graphing part 1. What's the slope? It's negative. Is it constant, speeding up or slowing down? It's speeding up. you don't include a value when you're doing acceleration. If something's speeding up, there is no value of the slope. So we'll have to figure that out in a second. So I'll show you how that works here once we do part 2. For part 2, we know we've got a negative slope. We know that it's constant. And we know that the value is -1/2. Okay? So here we go. Let's get right to it. We are going to start at time 0. Okay, we're going to start at time 0. We are speeding up, which means our velocity has to be getting bigger. And bigger can be more negative, right? It can be more positive, it can be more negative. So a bigger velocity, right? So look how steep this line gets. It gets really steep at the end. If this has a line, part 2 has a line of -1/2, this is going to be a lot steeper. So let's go all the way up to a velocity of 2 because we can. All right, so from 0 to a velocity of 2 in the first 1 second, okay, or -2 rather, in the first 1 second, that's what happens. Then in the second section here, number 2, we're going to switch to blue. This is for 2 seconds, from 1 second to 3 seconds. So from here to here, and it's a constant velocity of -1/2, right? So we need to find our -1/2. We need to mark it, and then we're going to draw a straight line all the way across. And that is it. This is part 2. This is part 1. That's the whole story, okay? So take these and go and do some practice problems. I'm going to post a second video with some more practice problems. They're going to look like these, okay? So we're going to do page 3 in a second video.